Good morning. My name is Jacob Chambliss. This is to be a law student. And our presentation is on the restoration of the observation lounge at the Air Discovery Center. Before we get into the presentation, we want to take a moment to acknowledge those who helped make this project possible. The Airview Aerospace and Science Museum, including Derek Menchinger and Sean Newton. Next, Western Michigan University and the Civil and Construction Engineering faculty, including Dr. Haynes, Dr. Lee, who is our faculty advisor, and Dr. Lee. We would also like to give further consideration to Eric DeJordan, Nancy Mulder, and Steve Ellis. Thank you all for your help.
The renovation law is located at the Airview Discovery Center. The Airview Discovery Center is located by the South Shore in the map. It's also adjacent at the Campus Butter Creek International Airport. As many as you know, like the Airview Museum is located southwest. The location, I will get the 3101 East Milman Avenue, Portage, Michigan. It's the main facility. It was founded in 1977. They do a lot of maintenance and restoration, and also they perform anti aircraft. You can see the airplanes from the facility. They have in the second floor, they have a training center, and they also hold their different events. In the background, the observation lounge room was added to the restoration center in 1991. It has multiple purposes. Immigration area for visitors, break room for envoys, and also access points for the arriving file. And also has exactly an excellent view for the runway from the Butter Creek International Airport, where the visitor can see the planes arriving and departing. Reason for replacement. The viewport has been 30 years in operation, and because of the glass pane close to toward the sun, there is a little doubt. And because of the residue unstructured damage, there was a leak in water into the flooring carpet and dissolving mold. And because of that, we have been deciding to remove all of that. It's not an easy replacement, it's a complete demolition and redesign. And that's where we decided to be the first option for the viewport and for the flooring output. Secondary improvement. Once the location taken the presentation for the lounge room, we have taken like the presentation for the secondary improvement, which will be adding a countertop in front of the viewport along the wall, which the visitors can sit in students and watch the airplane arriving and departing, while also listening to the chatter of air traffic like in the room. And also for the break room, which contains microwave, refrigerator, and also coffee bar for the employees, will be expanded to the 2 columns, and also we will be replacing the model component wall and replace it with the interior wall simplified small wall. Scope work. We have breakdown or scope work for components. First component is floor layout, which works include AutoCAD 3D drawings, lounge room area evaluation, and also available free space calculation. Our second component is key design parameter, which includes flooring, analyze alternative, and also people analyze alternative. Our third component is structure, which includes the steel framework design, and also reinforced concrete wall design. Our fourth and last component is construction plan, which includes transit, exterior transit plan, working cost, and working perspective. Here is the front door layout. We are getting a table, the two different diameter, the 3 chairs to each one of them, and 2 big tables to the chair. As you can see, there are no clear pathways from the final floor, which is the bottom left floor layout. As you can see, a little bit of problem. We have also to expand the break room to the 2,000 line it will be, it's now 12 by 11 feet. Layout consideration. I'm going to take in this consideration, like while we are doing the secondary working, there will be a vacant additional space. And by that, we make it be constrained by the current temperature, the lounge room, with the renovation to expand the area about a couple of hundred square feet. So it will get like, it's not in the upper floor. So we were trying to, while we are knowing we're reducing the amount of space, but we're still trying to maintain the same amount of area space table and the amount of seats as well, and we're still providing the same pathways during the doorway. Here's the updated floor layout. As you can see, there are 7 horizontal tables with 6 chairs to each one of them. And also, as you've seen, we have added the countertop along with the viewport wall. Also, in the blue line, you can see that the clear pathways going from the bottom to the right-hand side of the door, and also to the back of the building. We have expanded as well the break room to the 2,000 line, which now approximately will be 19 feet by 13. The floor layout comparison. The break room size for the first one, it is 129 square feet. If with the updated design, it will be 228 square feet, which is about 99 square feet. And also for the method you can see, for the current design, it will be 100 people. But for the updated design, it will be approximately 93 people, which is about 15 square feet per person. For the number of tables, for the current design has 12 tables, as we said before, but for the updated design, it will be 7 tables with both the average. Last but not least, for the amount of seats, we try to give the same amount, which is 42 seats for both current and updated design. We have shown you the floor layout, but now we're going to show you the viewport layout. We have the current design, floor design, and the design. For our current design, it has angle glass, curved and vertical glass as well. But our curved design has both extension, curved and vertical glass. Our vertical design has just two extension and vertical glass. We have added the current design, it's just like the full base, but to compare to the other two. But for the curved and vertical design, we can tell it's way much better than the current design. And why is it intuitive for people? We have for the 3 options, we consider the 5 criteria. The cost, lifespan, serviceability, visibility, and stakeholder. We have given the criteria weight out of 100. The current design was built in the 90s and still no longer available in the market. However, the curved design is also time-consuming to make glass and also too expensive. For the vertical glass, to make this curved glass, it will be increasing the lifespan and serviceability. It will be decreasing the visibility for visitors who want to see the plane arriving and departing in the runway. And also, because of the criteria we gave and the score, the vertical design was by 650 out of 1,000 compared to the current design, but with 385 out of 1,000. Here is what it looks like right now for the construction model. And this is what it would look like. And like the project for the living, we have chosen the 3 carpeting, laminate, and tile. For the first criteria, it tries longevity, management ability to mold, and appearance. As you can see, we have chosen the project, which is the current right now. We know it's not going to be the optimal option, but we just want to compare to the other. You can see the tile here, the expensive one between the other two, If it's closed, then you have 50 years market life and also loss ability to move. However, at the end, with the score given, with the review rate as well, the current one with the 615 up to 1,000 compared to the targeting, which is 355 up to 1,000.
The decision to remove the current self-supporting viewport in favor of replacing it with a strictly vertical design mandates a structural design capable of supporting both the new roof extension as well as the exterior walls. This structural design will incorporate both steel and reinforced concrete. Before we get into the drawings and calculations, we need to go over 3 assumptions that need to be made in order for this structural design to be valid. The first assumption is that there must exist a foundation capable of being drilled into 16 inches for the purpose of rebar reinforcement. The second assumption is that the proposed steel framework will be able to tie into the existing roof and columns. The third assumption is that because of the new roof extension and its inevitable reduction in ceiling height, this will not interfere with the HVAC system nor the ductwork. Here are the calculations involved and the effective load combinations for the roof and the east wall. For the roof, the snow load is what is prevalent, load combination of the roof and floor, and the load of 37.626 pounds per square foot is applied to the roof. Meanwhile, for the east wall, the wind load is what is prevalent, load combination number 4 controls, and the loading of 29.732 pounds per square foot is applied to the east wall. These loadings govern the sizes of the steel elements shown in the following figure. 1 inch thick, 22 gauge steel decking is to be fastened to 9 12K1 bar joists spaced 24 inches off center. These bar joists are to be top connected to either W813 or W818 lateral beams, spanning east to west. These lateral beams are pin connected to W8 by 35 watts tunnel beams spanning north to south, as well as HX as 4 by 4 by 1/4 columns. These 9-foot tall columns are to be welded to a steel plate that is bolted into an 8-inch thick, 3-foot tall concrete wall. The forces exerted by the columns on the concrete wall result in a maximum shear of 5.757 kips and a maximum bending moment of 35.484 kip-feet. With this in mind, 2 number 5 size horizontal rebar is sufficient for layer reinforcement. Stirrups are not required. However, ACI 318-19 states that a maximum spacing between rebar 18 inches is necessary for shrinkage and temperature requirements. Because of this, 3 layers of 2 number 5 size horizontal rebar are necessary for the 36-inch wall structure. Here is the side view of the concrete wall section according to proposed column number 2. 3 layers of 2 number 5 size horizontal rebar are spaced a little bit more than 16 inches apart, while 2 number 5 size vertical rebar are 36 inches long, with 16 inches extended into the foundation and 20 inches extended up into the wall. These lines of vertical rebar are spaced 18 inches in the center in comparison to the center of the columns, as well as underneath each line of the J-type anchor bolts. At line AA, this is what the cross-section will look like. The 12-inch long J-type anchor bolts will be tied into the top layer of horizontal reinforcements, while the vertical rebar will tie into the middle and bottom layers of horizontal reinforcements, which further secure all the structure together, considering that stirrups are not required. And to conclude with the structural design, this is the top view of the concrete wall. One new dimension that's shown here is the spacing between horizontal rebar in the same layer at 4.375 inches. Now, getting into the construction plan. We have to take into consideration the implications of working near the Kalamazoo Battle Creek International Airport. A provisional security fence of at least 10 feet in height is necessary to comply with TSA regulations. An AZO badge holder with export privileges will also be required to oversee certain tasks on the exterior of the building, which includes the mobilization of equipment into and out of job sites. Attempting to move equipment in from the north is not recommended because it will likely cause damage to the grass and exterior pedestrian walkways. Because the equipment is going to have to come in from the south, and because it's going to have to come in from the air operated area, it is recommended that the air suit rent 2 scissor lifts and 1 8,000-pound forklift. This decision minimizes the amount of hassle when trying to deal with different contractors bringing different pieces of equipment at different times and dates, and also provides the air suit more control over the project. Here is the exterior transit plan while construction is ongoing. As previously mentioned, equipment will come in from the gate to the south of the Discovery Center. A temporary fence of 110 feet in length will surround the observation lounge, and there will be a 10-foot wide gate to allow equipment in and out. Workers, meanwhile, will park in the northwest of the Discovery Center and come in from the northbound foot. With the higher entrance of the observation lounge temporarily unavailable, the currently unused gate system shown by the green star will have to be retrofitted to allow arriving pilots and crew access into the facility through the main lobby. The Gantt chart shown here establishes that the schedule starts on September 12, 2022, when in reality, the actual start date is on. But in order to satisfy the logic utilized in the schedule, the project must commence on a Monday. Also, the accuracy of the schedule is dependent on all of the layout, structural, and planning considerations being properly addressed. With all that in mind, the anticipated duration of this project is 61 business days, which is equivalent to 13 weeks or approximately 3 months. Here is a summarized cost estimate broken down into major line items from the structural steel to the flooring. Assuming an overhead and profit of 20% and a contingency factor of 5%, the total cost comes out to $207,249. And just for context, the observation lounge is contained within a 47-foot by 35-foot space. Whether following the aesthetic trend of the 90s, like the Wendy's fast food suburbs that people have probably seen, or just being the most cost-effective option, the current viewport is not sustainable. Trying to recycle all of the demolished materials with all the residue and mold is going to prove very difficult. The paramount goal of this project was to make another redesign of the observation lounge unnecessary, to where subsequent renovations merely involve the replacement of individual components, such as and brakes. We sought to create a long-lasting and serviceable viewport, and we believe that the structural design proposed in this presentation and in our report does just that. To conclude, we updated the lounge floor layout. We selected a vertical glass viewport design. We developed a structural steel framework and reinforced concrete wall. We generated a project estimate and schedule, all to help the air suit make informed managerial decisions on the renovation of this observation lounge. Questions?
Jacob, could you elaborate how did you design the steel frame? Do you use any software or did you just do manual calculation?
I did manual calculations. I haven't. So I included in the slide calculations specifically to the lateral beam for 2. which comes out to a W8 by 18. And then I give a report. I add both shear, reaction, and moment diagrams, not including self-weight, and then once determined after including self-weight.
You guys, sorry. My second question is, you're building a concrete wall that's gonna on top of the existing foundation concrete wall, right? So how do you, and the steel rebars, how do you make them, an integral steel connection? I mean, see this.
In the production of the cost estimate, we considered using ties as specified by us in the software. In terms of the structural design, I guess I made an assumption that there would be ties available to put together or to connect together the J bolts to the top layer of horizontal rebar and the vertical rebar to the middle part. Does that answer your question?
No, I'm talking about the wall, concrete wall will sit on top of the foundation wall, right? How do you connect the new build concrete wall with the existing foundation wall?
So there's I guess there are two components, and one of them I did not discuss in this presentation. One is as I said, the vertical rebar, and then the other one is that we made a recommendation to the report to use, as we discussed, the epoxy adhesive that's according to, I believe it's like ACI 48 or something like that. And yes, you have to do certain preparations to the existing slab in order to make that possible. And there's in the report, I summarized all the steps that need to go into that to make sure that this is good.
Thank you.
Yes.
Your design, notice the last picture from P17 part. Can you consider it prop wash in calculations?
No, I didn't. I used when coming up with the wind load, I used online. There's a software called ACE7 Load Hazard, and I established the assumption that the observation mount is a risk category number 2 structure, and then I came up with the applicable wind speeds. I believe I have that broken down, or I won't have a slide on that in the presentation, but it is in the
Yeah.
So, well, for the FAAs, I actually work for a crane company, so I know I actually have, for our company, we actually have the FAA permit specifically for this area. So in terms of that, I know all the procedures to go into that, but in terms of FAA, in terms of what people work, one of the things that we discussed to be touched on is the constraint by the current perimeter of the lounge room is that when we consider trying to expand the room a couple of 100 square feet in order to accommodate the reduction in the secondary improvements, and Eric Bajor helped us out, the Promise Valley Airport helped us out with that. There is a lot of paperwork to go through. The TSA, the TSA, the FAA, the airport itself, and those assumptions are established in the report, and there are associated documents in the appendix that show some relevant documents related to this.
Good question. Well done.